Hi there, welcome back to the channel, and in today's video we will be dimming an LED with PWM control. That means pulse width modulation. So that means by controlling the width of a pulse, we subsequently control the brightness of an LED. So let's get into the programming so I can show you how this works. From the machine library, we will import pin, PWM, which is pulse width modulation, and ADC. ADC means analog to digital conversion. More about that in just a minute. And from time library, import sleep for the delay. So let's start defining the pins. LED pin, we've been working with that on GP16. LED equals pin class, LED pin, pin dot out, since it's output. And now let's define the potentiometer. We need to convert that analog reading from a potentiometer into a digital reading. That's why we need ADC, so we can interface it. Interface the analog reading of the potentiometer, convert that into a digital reading, so we can work with that on MicroPython. So next step, we'll just make another variable to show you what changes here, and we'll just take the ADC value of pot pin, which is GP26. If you refer to the PyPico diagram, you will see that GP26 is in fact an ADC pin. If you try to do this on a pin without ADC capability, this won't work. So that's important to keep in mind of that. Now let's start defining the PWM, since that's what we'll be working with. Lowercase pwm is the variable which is equal to the PWM class of the LED. And then we can define a frequency for this, just like this. Let's choose a frequency of 1200 and a duty cycle, which is what will be coming from the PWM, and we'll initialize that as 0. Okay, now that's all ready. Let's make the infinite loop. And in this infinite loop, we'll have a potentiometer value, which is equal to the reading of the ADC value from the potentiometer as an unsigned 16-bit integer. Now, what do I mean by 16-bit integer? 2 to the power of 16 minus 1 is 60,000, okay, 65,535, I believe. That's 2 to the power of 16 minus 1. That's the usable value we can work with. Just to let you know about that. So that will be our maximum value of the potentiometer. I'll show you in the console when that's all ready. And with that, we can use that value from the potentiometer to control the PWM duty cycle. Another 16-bit integer duty cycle of the potentiometer value. Print the potentiometer value so you can see what's what, and a sleep to add the delay to reduce CPU usage. Okay, now that's all ready to go. Let's wire the circuit in the breadboard. Okay, so just a quick word on the code before we begin. I've adjusted the sleep value here to 0.1 because that would 0.5 seconds was just a bit too much delay for the LED to respond. So if the delay is too large, the LED will respond slowly to the turn of the potentiometer, and we don't want that. So now let's start building the circuit. So here we have the wires, the breadboard and the Pico, the LED, the resistor for the LED, and potentiometer. So let's begin by wiring the LED. Let's position it here. I'll just make some space for the potentiometer later on. Now remember, we're connecting it to GP16, so just for good convention, good practice, I'll put red wire on 16 and brown wire going to ground. I'll connect the resistor now here to the positive leg of the LED. There we go. Red wire going here, brown wire going to the short leg or the ground leg of the LED, just like that. And now here we have a potentiometer, so a little word on this. So in this casing there is a resistive track that increases the more I go this way. Or at least it varies, maybe not increase. But what that means is that it's kind of a voltage divider, so if I put ground here and a voltage here, as I turn this, that will affect the output. It's like a voltage divider circuit. So let's start wiring this. So I'll put the ground leg here, going to ground on the Pico. Brown wire, 3.3 volts. And we'll take the orange wire as the signal wire, or the output that we're interested in, going to GP26 on the Raspberry Pi Pico. So now that's all ready to go. Let's run the code. And there we go, there we have it. A dimmable LED using PWM control. So as I turn the LED, not the LED, the potentiometer, the LED brightness varies just like that, using PWM control. And you can see on the console display here that the value changes. If I turn this up all the way, so now that can't go up anymore, value is 2 to the power of 16 minus 1. That's approximately 65,535. Okay, now let's have a look at PWM. So here I have an oscilloscope that is powering up now. So let's make the connections to view this on the oscilloscope. So I'll connect the probe to the positive leg of the LED like that. And I'll just get this ground clip on the short leg of the LED. Is that on correctly? Okay, now that's stable enough. So now we can see that right now we have 100% duty cycle because it's at the maximum value. If I turn the potentiometer now, okay, it's a bit unstable, but it's good enough. You can see that as I turn the potentiometer, the duty cycle decreases. As I turn it back, it goes increasing to 100% duty cycle. Down again, you can kind of visualize that. It's very important and a good skill in general to be able to visualize things. And this is a good tool to do it. So theoretically speaking, this is what PWM looks like this. So we have 50% here is kind of half on, half off. 75% duty cycle is on for 3/4, off for 1/4, and vice versa for 25% duty cycle, on for 1/4, off for 3/4. So that's some basics there about PWM. That's a good way to visualize it there. And here is the dimmable LED. One more time, just for your convenience and mine. So there we have it, a dimmable LED made with MicroPython programming using a Raspberry Pi Pico. Thank you very much for watching.